Hey, and welcome to the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. Here, we dive into the cutting-edge worlds of prototyping, aerospace, rapid manufacturing, high-velocity mass customization, and beyond. I'm your host, Jordan Rose. Joining us today is Jake Schmidt, engineering manager at AMP, a company that's changing the game in waste management by merging AI and robotics into real-world solutions. Jake started at AMP in 2020 as a senior mechanical engineer, and just recently stepped into his new role as engineering manager. He still spends most of his time hands-on, designing and building, and the company's latest small-scale robot is entirely his design. Welcome to the show, Jake. Hey, Jake, welcome on the podcast. I'm super excited to chat with you today. You've got a breadth of experience in very complicated advanced technology for the recycling industry, using robotics and AI, and I'm excited to learn more.
Yeah, Jordan, I'm glad to be on. I'm excited to talk about AMP. I feel like we have a lot of great tech that I think is really making a difference out there. So it's a cool thing to be working on.
I love it. So you were telling me offline before we started that you're newly the engineering manager at AMP, and you've previously been a senior mechanical engineer. Can you give myself and the audience a rundown of your professional history, your educational history leading up to starting at AMP?
Yeah, graduated '09 in mechanical engineering, and then I've gone through about 7 different jobs in a bunch of different fields. I worked in floor cleaning machines. I worked in electronics. I did a stint in a little bit of aerospace. I also designed aluminum can machines, specifically a decorator. So a bunch of different things, a lot of different types of work. I worked in the railroad for a while on railroad maintenance machines. So big industrial stuff, electronic stuff, consumer things. So a pretty wide berth of stuff before I landed at AMP about 5 years ago.
Very interesting. So you're a man of many hats. What does your role look like currently at AMP? So as a senior mechanical engineer and engineering manager, what are you doing there?
A lot of what I do is facilitating like kind of new design projects that we're working on.
Mm-hmm.
I take a lot of the stuff. Historically, I've done a lot of work on our robotics side. I designed a lot of the platforms from the frames and the cages and the interactions and a lot of like the safety systems and locks, kind of how a whole robotic system goes together. And I was kind of like the main engineer for a lot of those types of projects. I was kind of a lead and helping other younger engineers. And now we've kind of moved on to facilities. So I do some maintaining stuff in the robotic space, but a lot of new designs on things for the facilities, new types of cameras, new types of like NIR technology of things to blend into it. And I'll take all of these things as kind of concepts and bring them forward to like I actually build the first hands-on prototype, make sure it all works, and then work with either operations or assembly to make sure it all gets built and all gets installed correctly. So just this wide berth, as well as a bunch of like projects that don't fit anywhere else. I work on a lot of little special projects of, software needs this particular calibration fixture, or they need these particular sensors built and installed to do this monitoring of the recycling process and of the outgoing materials. So there's a lot of just a little mechanical things that come into that building of all those things. And I handle a lot of those things, and like my department gets a lot of like the edge case stuff of like the little things that don't fit in like a big overall facility layout. So it's been a widespread, and I've worked on a lot of different things going on, but it's a lot of like, I get to build and R&D a lot of things. I also occasionally build like fixturing and those sort of things. There's just a lot of different stuff going on, and I'm kind of see myself as like facilitating getting these big projects done by helping to like, build all the little details.
Very interesting. So yeah, it sounds like you have your hands in a lot of places. It sounds also like AMP is doing a lot of different things. You mentioned robotic systems and also facility design. Can you explain more to us about what AMP does?
Yeah, absolutely. So kind of the core of AMP is using AI to identify things in a waste stream. So we use a camera, the material flows underneath it. That camera basically takes a picture of everything and runs it through our neural network that we've built one item at a time and identifies different sets of things like plastic and, like PET, HDPE. It knows different types of cardboard, paperboard. It has a lot of different, we have up to, I think it's about 60 categories of things
Oh,
that the
wow.
neural network can identify. So, yeah, like way more than you'd think.
Mm.
And like a traditional recycling facility will only be identifying like 4 or 5, and most of it will be sorted by hand. And we have this very configurable system because we're using AI, and we can continue to upgrade it, and we can make it really flexible on what it's sorting. That's kind of the backbone. So we started with that backbone paired with a robot, which just uses a little vacuum cup and grabs the item and sorts it off the belt. And so we work with an existing recycler and we install a robot into their system. And now instead of having someone sort it by hand, you've got a robot that sorts it automatically. And that works well. And we installed hundreds of those systems, but we got to a point where you can only go so far with that market. And really, the best market is we already trained that AI, and now we want to use big, large systems that basically use little puffs of air to sort. That whereas
Mm.
a robot's limited to something like 100 picks per minute, our facility systems will do like 1,500 picks a minute. It's wild, and they can sort it into multiple places, and those form the core of the facility. And we'll have, depending on the size, anywhere between probably 12 and 16 of those systems that can be configured to sort anything.
Okay, that's really really cool. So you're talking about a order of magnitude performance increase using the facility system that uses air to pick the waste off of the line. Who are your customers? Are these municipalities, cities, private organizations, waste management organizations? Who is coming to you guys, and why? Obviously, the benefits on paper seem like a no-brainer, but what is it about what you guys do that is so appetizing to your customers?
A lot of so the original robotics business made a lot of sense for people, and it's like big recycling, so waste management and waste connections and like those sort of big recyclers. They are a lot of the buyers of our systems, but we've also sold to municipalities like smaller, counties that run their own recycling. But whoever runs recycling is who we kind of aim those sales at. And a lot of times they're having trouble getting people to show up to
Mm.
work because it's not a really great job to have. Like sitting there all day and grabbing dirty material off of a line and throwing it into bins is a hard job to get someone to stay at. So like turnover is high, and it's hard to get like really consistent workforces to, especially if you want to run multiple shifts. So
Yeah.
like if you're running multiple shifts, the robot doesn't care. Like you need a little bit more maintenance, but like it'll work all day. Um, and then past that, when we're doing facilities, our customers will be like cities. Like we'll contract with
Okay.
them to take waste, and we'll be like, we'll divert X amount of it so it doesn't go to the landfill. Your landfill lasts longer,
Mm.
and it's this overall win of being like, we're going to take all this stuff out of stuff that was like, and we've gone past recycling too, of just being recycling bins to full on just municipal waste. Like if it went into a waste bin, we pour it into our system and it sorts it out. And we're running a facility like that currently. So everything you get out of it would have gone to the landfill. And all of that diversion makes landfills last longer. And then we're basically taking that stuff off the top as cream and selling it.
Absolutely. So there's a lot of benefits, both with flexibility with your labor pool, so you don't have to worry so much about that, and then also the overall reduction in amount of waste and the cost and management of that. That all makes total sense, and the benefits of that. I'm wondering, as you referred to earlier, you're kind of involved in a lot of different subsystems or system development projects for AMP. Can you tell me a little bit more about some of the, I guess, core project management ideologies or project development ideologies you follow or you and your team follow, given that, these projects, like I can imagine designing, a full facility system is pretty complicated. There's a lot of subsystems. How do you guys make that all come together?
I think a lot of what's made us really successful is starting absolutely simple. Like, what is the very minimum amount of things I can use to get this system built and done, and then prototyping that and iterating on it. A lot of stuff I build, like I've taken things that you're like, man, this has a lot of parts to it. Like, what is its basest element, and then having the minimum number of people in both working on the project and in the meetings. Um, from an engineering side, I feel like, a lot of times you get a lot of cooks in the kitchen really early, and we've had projects where you know product thinks it should be this, and like management thinks it should be this, and maintenance wants this, and you'll have 20 people in one of the first meetings to try and figure out what to do, and you'll end up grinding in that process of figuring out what you want to do, and at that same time nobody's solving any problems. And if the
Yeah,
first time you go, what is the core problem? What's the simplest way to solve it? And how do I get a prototype going that starts parameterizing how to solve that? The quicker we get to that point, the faster the whole process moves and the better results we get at the end. So I feel like that's how, as I drive things, how many people does this need? What's that minimum number? And making sure that we're not trying to overcomplicate stuff before we need to.
I love it. It's so congruent with the ideologies that we talk about internally, right? We use different language, but very much the same. And it's what we at ProtoCase, ProtoSpace, the family of businesses that support folks like yourself. We pride ourselves on it is enabling what we call project velocity, right? And that's really what you're talking about. And you're talking about other things that we banter around a lot, which is lean project development, duct tape solutions. So what's the minimum that you can put together? The simplicity of things, as you mentioned. And that's really to get to what we call end-to-end moments, which is figuring out how this is all going to work as quickly as possible and moving at velocity. So it's really good to hear that, what we're doing is resonating with you guys, and that we're doing things internally very similar to the way you guys are doing it, which is great to hear, because obviously you guys have had a lot of success. I wonder if you're going to take that. You mentioned again off the hop that you're now kind of transitioning into your role as engineering manager, being a senior mechanical engineer for a number of years with AMP. Are there anything that given your experience with mentorship, is there any sort of, leadership ideas that you have when you're now jumping into this new role, and how you get your team of people aligned with those methodologies, keeping things simple, moving fast, and figuring out how the thing works as lean as possible? How do you think you're going to do that?
So luckily enough, the first member joining my team was someone that's been an intern for us for the last couple of years, and he's been reporting to me that whole time. So I feel like we've kind of steeped him in the culture, and he's been working like 10 hours a week during the school year.
Awesome.
So he's also really on board with the quick turn prototypes and figuring it out, and just being like, it's okay to make mistakes, but just don't end up in this situation where you can't make a decision. Like, I feel like it's just important to think about it, and once you're done thinking about it, just go do it. Because I feel like it's really, like, as a young engineer, it's super easy to get stuck in well, I don't want to make a mistake, and you're like, dude, you've already made mistakes, and that's okay, and like, I don't yell at you for those. Like, as long as you go fix it, we're fine. So like, as a leadership strategy of being like patience, but understanding, like, here's the goal. What's your goal? What are you doing next? And how are you driving towards that? And trying to get that it's okay to make mistakes, but we want to go, like, we want to figure out where we're going. Like, is this step I'm working on now the thing that's going to get us forward? And if it goes a certain way, what's my next step? So trying to think out, like, how you solve problems in a logical progression, and understanding where that ends up as like a really good solution or a product.
Yeah, absolutely. I can't tell you how much this resonates with me. The term we use often is we have patience for results, not for execution. And something that I've noticed in mentoring young engineers, and I really think that it's our education system that does this to these young engineers, myself included. But it's almost as though the the testing and the need for perfection throughout your education, your educational career, breeds this decision fatigue, where all of a sudden people come out and they're super smart people, but they're like scared to make a decision. And oftentimes it's just make a decision, and as long as it's a small enough risk, you can often recover for it. And as you mentioned, I'm never going to be upset with you for making a bad decision or making a mistake. I'll be more upset if you don't make a decision at all.
Yeah, like I want to move forward. Like, hey, like if we were working on a part and the injection molded part didn't quite work like you wanted. And you're like, well, we spent all this money on the tooling. It's fine. It's fine, buddy. We have
Yeah.
money. Like, I know how much I'm getting paid, and like I make mistakes. I break stuff. That's okay. Like, it's not a problem. But like, how are you gonna fix it now? Like,
Mhm.
do we need to make a new mold? Do we need to modify this mold? What are we gonna do? Or like, this sheet metal part didn't, like, this hinge doesn't work right. And he's like, oh, I missed something. Like, yeah, it's okay. How are we going to fix it? Like, what's the next step to move forward? Because as a young engineer, and especially like younger in my life, my dad was kind of hard on me in terms of fixing stuff. Like, he was also an engineer, but real brilliant guy. But he'd be like, it needs to be done perfectly. Here's all the little steps. You can't miss any of them. And then I started working with some friends on like some mechanic work. And I'm like, aren't you going to do these things? He's the guys at Jiffy Lube do it with way less. Like, and I was like, he's kind of right.
Yeah.
There's a lot of people out there doing this work with a lot out that care to detail that still works. Like, it's important to like understand whole systems, but not everything needs to be perfection all the time. And allowing yourself the room to make mistakes, and like, but understanding the importance of where things are critical, or you're like, you know, putting the risk to reward ratio. Like, if I'm making going through a decision making process, how much is this going to cost? If the answer is less than a couple $100, just do it. If you think it might work at all, just do it. If it's a couple $1,000, maybe we should think about it for a couple hours. Maybe bring me in on it. Like, we can talk about it together. Like, that's enough risk that like might be worth a short meeting. If it's like 10, 20 grand, you're like, maybe we get 5 or 6 people in here. Maybe we like get a few more people to look at it, but sometimes not. Sometimes we just like, if we're depends on how sure we are of the answer. And like, if we've done this before, it's similar to something else. Like, it's okay to make choices. It's okay to like, if we think we can work with it after it gets here, it's important to do it now. And then if we spend 2 weeks we don't, then that's 2 weeks from when we actually get the work done. So,
No,
just
I couldn't
yeah.
agree more. It's just it's amazing to listen to you talk about it with this passion. And I'd love to piggyback off that, because one thing that stuck out to me in your bio is that you are heavily involved with mentorship. I think both in the professional setting and then also in the volunteer setting. You've obviously got all this knowledge, and you and I are definitely aligned on so many things. Can you tell me how you mentor either students or young engineers on your team, to be better and to grow and to learn the things that you know?
I feel like a lot of the stuff that I know is more onto, let's think about how we could easily build it. Let's
Mhm.
think about how to make this really simple. What are our tools at hand to make a prototype, and because a lot of, I feel like I add a ton of value is being able to quickly get to a solution, of being like, we could spend 6 months designing this all out, or we could get this base element, add the motor to it, add a fan, do it in 4 days, and get us an answer that's going to direct how we go with the rest of this program. So when I mentor kids for, say, things like robotics, a lot of the time it's with a lot of the robotics, when it's like high school students, I'm
Yeah.
teaching them a lot of CAD. I'm teaching them how to think in 3D space, and you're like, when you do CAD, think about how it's actually going to be built in real life. Like, what material are you using? Like, could you buy something off the shelf that does this? Here's how to download off the shelf parts. This is going to be super important. This will, last with you for your whole engineering career. Like, stuff off McMaster is great. If I can just have one for my prototype or whatever, sometimes even in production, if it's a good enough thing, understanding all the tools at your disposal to make those answers. Also, like, I feel like a critical part of the engineering process is actually building things.
Mm.
Like, the more you see things go together, the more you can plan how you're going to design and build something in your head. Some of my favorite parts are teaching younger kids how to use power tools and grinders and stuff. Like some of my favorite pictures of the kids just like shooting sparks like 5 feet with just the biggest grin on their face. And you're like, yeah, he's gonna like that. So I feel like a lot of really good mentorship is like, how do I make this something fun? Like what if I'm trying to get kids into it? Like there's a lot of like dull stuff that goes on in the process, but I really try and get them to see that a lot of it's really fun. Like, and if you can kind of focus on, really hyping up the fun stuff, that, those skills, you're like, look, it's actually building things. Or like they program a CNC for the first time and watch cut something. You're like, oh, or like, 3D print something and watch it start to build it. You're like, this is neat. I get why this is fun. You're like, I get why it's fun too. I love that. Like the passion is like what I really try and enforce when I'm trying to teach all these different skills and what all these tool sets are available for them to like apply to their whole life.
Yeah, I mean, it's incredible. It sounds like you're so passionate. And again, in the same way, you have your hands in everything at AMP. It sounds like you have a very wide reach in terms of mentorship as well. What fulfillment do you get out of mentorship? Can you articulate that for me?
I have a general philosophy that like, we should be doing good things for other people. And I feel like I've had good mentors and I've had good teachers and I've really appreciated that. Like the people that really like stood out and like I had high school teachers that went like well out of their way to go do really like nice things and be like to get you excited about learning. And I don't feel like everyone gets that experience. And the more that I can come be a part of something like that is helping to like make sure that the next generation of people who are going to solve problems of the future have like some of the information that I have. So I feel good when I do it. Like I really like that feeling of like when I'm done mentoring kids and I see them succeed and I see them get excited about building something, I get a really like there's a high sense of value about just that just good feeling about you're like they appreciated this and it looks like they're going to use some of this information that I gave them and they had a good time building robots or whatever it is. So
Yeah,
I like it.
yeah, I think it's pretty amazing. It's pretty cool. I think you should be really proud of the work that you're doing. I think you're probably having a big impact on a lot of kids, and they'll probably look back and maybe on a podcast 20 years from now with whoever's sitting in this chair and say the same thing about their mentor. So hats off to you. I kind of wanted to end on looking forward for AMP and learning a little bit more about what's in the future for you guys. Obviously, cutting edge of technology. You're using AI to reduce the amount of waste that we put into our landfills. But what does the future look like for AMP? And I guess you at AMP.
The future for AMP, I feel like is really just we've taken that base of being like, here's the things that we're currently taking out of the waste stream and we can find value in. And how do we expand that into more places? And then how do we find more things and more ability to make separate waste streams that now have value? Like with being able to take sorting down to, it's pretty expensive to have people grab it by hand and sort it. If we have these systems that can, ramp that number up, then the amount of things we can sort for value goes way up. And we're looking into things like what can we do with organic fractions and how can we get more of that out and other types of materials and what can we use them for and like how like if we get 30% out of everything that goes into the trash can, how do we make it 50? How do we make it 60? Like how do we work as like kind of force for good to be like if we have people working in legislation to go, here's things we should do with materials producers that would make it better for everybody that we like. How do we get that number of the things that go to landfills as close to zero as possible?
Awesome.
So that's the big main driving goal of how do we use technology to make this better? And that's what I'm excited about.
Yeah, it's awesome, and I can't wait to watch what impact you guys have. It's really cool. I do think that it's absolutely the future, and definitely required for the scalability of urbanization throughout the world. So I think It's pretty cool. If folks listening are looking to find out more about yourself or about AMP, where would they find you?
Ampsortation.com is where our main website is. And if you look up Amp Sortation, or our old name before rebranding was Amp Robotics, there's a lot of news articles about us. There's been some Newsweek stuff. There's been some we were on in Times Magazine.
Oh,
that was
wow.
pretty cool. We've gotten a lot of good media exposure. So just Googling that, and you can read some articles, and there's a bunch of stuff about facilities we've opened and the tech and some of the going back some of the old robots and things. But yeah, it's been really awesome. It feels cool to see yourself in the news sometimes. So.
Absolutely. Well, Jake, thank you so much, and until next time, bye-bye.
Thanks. It's been good. Thanks, Jordan.